graphing y equals ax squared and y equals x squared plus or minus k. Okay, so this means there's a coefficient in front of the x. This means we're adding or subtracting something behind the x squared. Remember that y equals x squared is the parent function. It would be helpful if you memorized what this table looked like and what this graph looked like. So 0 is 0, 1 is 1, 2 squared is 4, 3 squared is 9. Coming back, negative 1 squared is 1, negative 2 is 4, negative 3 is 9. Notice this is a unique value, and these are the same, which means this is the vertex, and these are symmetrical to each other. My vertex is at 0, 0, 1, 1, 2, 4, and then here, and that is your parent function. Okay, now on your calculator, but what we're going to do is we're going to do this here, and we're going to actually look at here, and we're going to extend our table, and we're going to do the same values, and this is y equals 2x squared, and the 0, 0 is going to stay 0. The 1 is going to go to 2. The 4 is going to go 8. The 3 is going to go to 18. 2, 8, and 18. So we're still going the same amount to the right, but then we are going up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so automatically you are seeing that it's still a parabola, but it is much more narrow. And then if I did y equals 5x squared, and I extended this table, and I did here, it would be 0. Still, I'm not messing with the vertex. This would be 5. This would be 20. This would be 45. This would be 5, 20, and 45. So again, I'm going the same amount of distance out, but the very first one is even narrower, and it becomes way narrow. Okay, so what is affecting it is this coefficient right here. If y equals ax squared, this is what makes it narrower or wider, and this becomes narrow. So the parabola stretches. You need to know that word, and it becomes more narrow. So if you had a rubber band and you had it like this, and you pull here, it would cause it to stretch and become more narrow. Okay, but the vertex doesn't change, it just is pulling, it's just pulling this narrow. Likewise, we're going to have on your calculator, or you can just do this, we're going to do it on a table, and we're going to do half x squared. So again, y equals 1/2 x squared. It doesn't affect the vertex. that becomes 0.5. That becomes 2. This becomes 4.5. So if I have a parent function, and this is 1, 1, and this is 2, 4, I'm now at 1/2. And then I'm at 2. Sorry, I'm at 2, 2. And you'll notice that it becomes like this. And if I did y equals 1/5 x, 1/5 of 9 is 9/5, 4/5, 1/5, 0, 1/5, 4/5, and 9/5. And so it's going to become even wider. And so how does x squared change? When the numbers are, the absolute value numbers are smaller than 1, the parabola compresses or gets wider. So I'm going to put a graphic here, and this is for A. As A is in this right here, as it leaves 0, it becomes narrower. And it becomes narrower. Likewise, yellow is considered compressed. So I'm going to say a phrase, and then you're going to have to understand what I mean by the phrase. So if I tell you that fractions make it fat, you have to understand that it's the fractions that are not improper. Because if I had y equals 3/2 x², that is actually y equals 1.5 x². Yes, I know that's a fraction, but it has to be a proper fraction in order to get wider. So this is actually not. So when it says the absolute values are smaller than 1, then I'm talking about only between -1 and 1. This causes it to be wider. As we go out, they become narrower on both sides, because the negative is actually going to do something else to the quadratic besides something else. So I can't say that the number's smaller than 1, because -5 does not. Y equals -5 x² is not a narrow. It's actually wide. It's not a wide, it's a narrow because of the whole number here. This negative actually reflects it. We'll get into that in a minute. So, basic information is the higher the number in front of the x², the narrower it is. The fractions with the higher denominators make it very wide. And that is how this A affects parameter changes of a quadratic equation.